Hello everyone, I'm IJCAI and I'm going to present you PyDL8.5, which is a library to learn optimal decision trees. I worked with Siegfried Nissen and Pierre Schoss. We were interested in working on decision trees because they are interpretable machine learning models, and there is recently a great interest for this kind of models. Indeed, there already exists some well-known algorithms to learn decision trees, but they are heuristic and sometimes they produce complex trees to achieve a good accuracy, and those decision trees are not interpretable. It is also proven in 2017 that depth-constrained optimal decision trees perform better than heuristic-based ones on many datasets. Since then, many approaches have been proposed to solve optimal decision trees problem in a short period of time, since the problem is NP-hard. The error criterion which is often minimized in the different approaches is the misclassification rate. The different approaches use different optimization techniques to solve the problem. The last approach, PyDL8.5, uses dynamic programming and branch and bunch search to find optimal decision trees. It is the most efficient algorithm to find optimal decision trees in a short period of time. In this paper, we present PyDL8.5, which is a Python library that implements PyDL8.5. Basically, PyDL8.5 algorithm is written in C++. PyDL8.5 is a scikit-learn compatible library, so it can be used in combination with all existing scikit-learn functions. Something interesting with PyDL8.5 is the fact that it provides a specific data structure called reversible sparse bitset to improve the result of PyDL8.5 in terms of time and memory. Here is a code snippet that shows how to use PyDL8.5 to learn optimal decision tree. You can notice that only 3 lines are sufficient for this task, and many parameters are proposed to constrain the search. Here is an example of how the code can be used. We can use different scikit-learn functions. We initialize the dataset here. We initialize the classifier with a maximum depth of 2 and minimum number of instances per leaf set to 5. We train the model and predict on the scene data, and we show some statistics. I'm going to run the code right now. You can notice that the result can be found in less than 1 second. We also notice some interesting properties about PyDL8.5. It makes an exhaustive search. It uses an upper bound and a lower bound which are not dependent of any error criterion, so the algorithm can be used to find any optimal decision tree for which error at a node can be computed by summing the error at the left node and the error at the right node. It is important to point out that many problems satisfy this requirement, so PyDL8.5 uses PyDL8.5 algorithm to provide an interface to solve all those problems, even though the basic algorithm was not designed to do so. To solve the 100 accurate tree problem, we just have to set the maximum error constraint lower than 1 and check that the goal is reached. For the clustering tree problem, we define a function for the error criterion and a function to name the found tree, the found leaf, and we pass those functions as parameter to the predictor to get our results. To get started with PyDL8.5, here are the QR code of the source code repository and the documentation. Thank you.